So in this problem, we want to use properties of limits to find this limit. Basically, we're going to find it algebraically. So the first step we try is plugging in c equals 5. And if I plug in 5 for c, we get 1/5 minus 1/5 in the numerator divided by 5 minus 5, which is 0 over 0, which is indeterminate. So we need to find another way to find this limit. So we need to rewrite it somehow. The technique I'm going to use is to multiply by the lowest common multiple of those two little denominators over itself. Another common technique is to get a common denominator among these two fractions in the numerator and simplify. This technique is just a little bit shorter, a little bit easier. So I'm going to multiply this big numerator there, all of that, by the product of these two denominators, so 5c. And we have to multiply by a form of 1, so I'm also going to multiply by 5c in the denominator. And let's add some parentheses here, because we're going to distribute this 5c over this numerator. So we have the limit as c approaches 5 of 5c times 1 over c. The c's cancel, so we're just left with 5 minus 5c times 1/5. The 5's cancel, so we're left with only c. And in the denominator, we have 5c times c minus 5. Now these two vectors are pretty similar, 5 minus c and c minus 5, but unfortunately we cannot cancel them yet because they're not exactly the same. But because they're opposites, 5 minus c and c minus 5, the terms are in opposite orders, we can make them the same by factoring out a negative from one of them. So I'm going to factor a -1 out of the numerator. If I take out a -1, then I'm left with -5 plus c. Now -5 plus c, if you look, that's the same thing as c minus 5, right? A plus b is the same as b plus a. Order doesn't matter here. They both have -5 and positive c, so those do cancel. So now we're left with the limit as c approaches 5 of -1 over 5 times c. And now we can go ahead and take the limit by plugging in that 5 for that c right there to get -1 over 5 times 5, or -1 over 25.